Hello and welcome back to Chapter 2 Testing throughout the software development lifecycle. Section 2.3 Test Types. Functionality of the system is what it does or how it functions. So, testing the functionality of the system is a test of what the system does. The non functionality attributes of the system are characteristics or constraints that can tell how it is achieved functionality. So, testing the non functional attributes of the system are meant to test how well the system does what it does. Non functional attributes are things like security, usability, and reliability. Each test type is selected to focus on a particular test objective. So it is best practice to know and use the different test types. Some test types focus on verification that all aspects of the software are tested. Some test types focus on the speed of the software. Then some test types focus on security. Using the appropriate test type or a mix of the appropriate test type always renders the best results. Different test types have different objectives, but most test types have the following goals in common. 1. Evaluating functional quality, like checking to make sure a feature or the entire system is working. 2. Evaluating non-functional quality characteristics, like checking the performance, security, and usability of the software. 3. Evaluating architecture of components in the system to see if they work and if they fit together in the scope. Here, the components should all be tested to make sure that they work, fit the workflow properly, and fit the scope to the project properly. Sometimes a review of the requirements is needed for this. 4. Evaluating effects of changes, which is the focus of confirmation and regression testing. We will talk about confirmation and regression testing more throughout the semester. Two point 3.1 Functional Testing. The function of the system is what it does. It is described in detail in the work product at the beginning of the project, like the business requirements. Functional testing is often called black box testing. An important concept for testers and their management is to understand that the following. Testing 100% of the parts in the system does not mean that the system is 100% tested. This can be interpreted in a few different ways. First, you can test 100% of the parts of the system as components, and then you can find defects when the parts are integrated together. Second, you can test 100% of the parts with very basic data or simple workflow, but that part is not really 100% tested because complications have not yet been tested. And third, after testing 100% of the parts in the system, the software will be moved into a real-world environment. Here, more defects can be found because the testing for this environment was not yet available. I am sure there are more ways to consider this concept, but those are just 3 examples that come to my mind when I read it. Functional testing should be done from 2 perspectives. The first perspective is requirements-based. It uses the specifications for the functional requirements as the basis to design tests, including the objectives, workflow, features, and data input. The other perspective is the business process-based testing. The other perspective is business process-based testing, which uses knowledge of the business processes. This viewpoint uses day-to-day scenarios that the average user would encounter. 2.3.2 Non-functional testing. Non-functional attributes of the system focus on efficiency, like how well or how fast something is done. Non-functional tests are done at all test levels for performance, stress, like the software capacity, usability, and security. The overall concern here is how well does the system work. White box testing is a type of testing that looks at the internal structure of the system. It inspects the system's architecture, code, control flows, business processes, and data workflows. White box testing is also called structural testing or the glass box testing. It is used to measure the thoroughness of the testing process through the coverage of items in the software. While white box testing can be performed at any test level, but usually works best at the lower levels, like the testing at the individual components or their initial integration. White box testing uses coverage measurement tools, which are tools that are used to measure this percentage of executable elements. This means that it measures the percent of the functions in the code or the tasks that can be performed on the site. 2.3.4 change-related testing. Change-related testing is a type of testing that focuses on changes like updates, patches, addition, or removal of features, and unintentional modifications of the software code. It is different from other types of testing because alterations in this software will change the way the system functions, how well it functions, and the structure. There are two types of change-related testing. The first is confirmation testing, which is a test to confirm that the change is showing in the software. The second is regression testing, which is a test to find the effects and side effects of the change. This is important because some of the effects and side effects are desired results, while others are not desired results. So both types of results need to be inspected. 2.3.4 change-related testing continued. Confirmation testing is also called retesting. An example of this is the following. A tester will find a defect in the software and report it to the developer. The developer creates a patch to fix this defect and adds the patch to the software code. Then the tester will rerun the test where the original defect had been found. Upon rerunning the test, the developer and tester can now see if that patch is in the software code and working properly. They can now confirm that the defect is fixed. Regression testing should actually be called anti-regression testing. In this system, a tester will have completed the confirmation testing and then they run many tests, sometimes all of the tests, to find any new bugs that may be unintentional side effects of the change of the software. The focus here is to make sure that the software has not regressed. 2.4 maintenance testing. Maintenance testing is done during the life cycle phase. It should be done regularly on a schedule and after any updates or hot fixes are installed. A hot fix is also called a +1 or a patch. The scope of maintenance testing depends upon the degree of risk of change, whether it is self-contained or external, the size of the existing system, and the size of the change. During maintenance testing, the main goal is really just to verify that the system is being properly maintained. 2.4.1 Trigger for maintenance testing. For maintenance testing, there are three main types. Modifications, like an update, a patch, or hardware exchange, can trigger the need for a maintenance test. Migration, like moving the system from one platform to another, can trigger the need for a maintenance test. An example of this is when one company absorbs another, or a change to the type of hardware, like going from a PC to a Mac. And retirement of software, hardware, or data can also trigger the need for the maintenance test. This requires the ability to archive and retrieve the data while complying with legal and regulatory standards. 2.4.2 Impact analysis and regression testing. Impact analysis and regression testing is Impact analysis is the inspection of the system to determine which parts need more regression testing. Some factors that contribute to the impact analysis are the following. 1, it's often affected by specifications that are out of date or missing. 2, test cases that are not documented or out of date. 3, bidirectional traceability is not properly maintained. 4, tool support is weak. 5, people involved do not have system knowledge. And 6, maintainability of software has not been taken into consideration. These factors can all be prevented or reduced with some properly followed procedures. The end. Thank you so much for joining me for Chapter 2. Have a great day.